final speaker of the session is Amir Rezvani. Amir leads the structural condition assessment practice at Infotek Solutions and has more than 10 years of experience in inspection, monitoring, sensing, and non-destructive evaluation of concrete structures. He is a certified bridge inspector, and today he will be talking to us about several of their field-proven innovative solutions and case studies in bridge inspection, high-speed sounding, and NDE.
Still this morning, so good morning everyone, and thank you very much for having me here. Well, Infotek is active in inspection and condition assessment of critical infrastructure. And within the critical infrastructure sector, we are actually focusing on bridges for a lot of good reasons. Now, since the day we were founded, we had this philosophy in mind that we want to actually make sure that we hire technology, we customize it, and we simplify its use so that it can help us do our inspection jobs better, faster, safer, with more efficiency, and having cost and affordability in mind. And that is what we are going to be actually talking about today. So how are we making this possible? What is our approach? It is kind of a threefold process that I'm going to go over it today with you guys. And I know that I'm like the last presentation of the conference, so I've actually loaded this presentation with a lot of videos, with a lot of pictures, so that I can keep everyone interested towards the end of the discussion. But now the very first, I would say, step in this approach that I just talked about is enhancing the current practice and infusing it with advanced technology and AI. So what is the current practice? The current practice is what we all know. It is visual inspection. So what we did was to bring technology, to fuse it with artificial intelligence, and help inspectors, and one of those inspectors is actually someone like me, to do our jobs better, faster, and again, more efficient. And something that Ben actually mentioned during the previous conversation was that this issue of, for example, time pressure that us inspectors have in the field. I mean, one of the biggest things that we had in mind was to bring in technology so that we can relieve inspectors from that time pressure that we all feel when we are actually in the field. And that is one of the things that really worked out in our favor when we brought in technology. No one would actually get bothered by having like an assistant called artificial intelligence or AI, or maybe we gotta find a cooler name for it, for our industry, to be active on his or her side, helping them with doing like a more thorough inspection job. I mean, I guess everyone is gonna favor that. And the second established practice, again, which has been around, I guess, since the very first day that a reinforced concrete bridge deck was around, is chain dragging. And we've all actually done it. DOTs and owners trust it, and it works. So again, as part of this established practice, we focused on chain dragging, and we looked at how we can actually improve it so that we can use it a lot more and we can get more out of it. The second actually part of this process is doing in-depth inspection. So by this inspection, where needed, we would actually move away from high speed while still we actually keep the highest speed in mind. But because we are going to go in depth, we gain a little bit more on one side and we lose a little bit more on the other side. But again, when it comes to the whole notion of inspection, we want to have this whole philosophy of, I would say, medical practice in mind. That there is like a triage, and then based on that triage, MRI machine is used, CAT scan is used, types of blood works are actually determined. We want to have the exact same philosophy here. That if you've got an inventory of bridges that you want to actually, plan something for them, I mean, do a program, rehab preservation. First, we can actually have like a very data-driven approach at, super high speeds from the whole inventory. And now, based on that data, based on the quick analysis that we're going to do on that data, we're going to decide that, let's say, out of these 100 bridges, some of them are in a very good condition, we can still leave them intact, that they can live for quite some time. Some of them are so bad that, no more blood tests or no more, for example, MRI is going to be required on them. But there's just this sweet number of bridges in the middle that would benefit more from an in-depth inspection, which is like this MRI thing that we want to do. But again, when it comes to the in-depth inspection, we want to make sure that it is automated. We want to make sure that it is standardized so that we can actually take it from place to place. We can actually make apples to apples comparisons. And we want to make sure that we are not really tied to a certain technology or certain sensor, and we are not biased, because we know that each one of these different technologies that are out there, they give us the view into the structure from like a different angle. And we want to make sure that while we are out there, we get as much as possible with as much variety as possible, and with a lot of, I would say, high quality, because you want to make sure that what you're gaining is what you can actually work with, and that is why, quality control, ongoing and automated, is very important here. And then at the end of the day, for all the owners, the solution got to be affordable, and they got to have proper return on investment on it. And the last piece of it is, again, us as inspectors, owners as decision makers, you would like to make sure that the results that you get answers your questions. You want to make sure that you can have confidence in those answers, and you want to make sure that they are actually gained through reliable methods. And that is why how we package this data, how we introduce it to you, how we actually give you the flexibility to even work with some of these scenarios and run and simulate your own scenarios come into the place. And that is the last I would say kind of part of this approach. So quickly going through the enhancing the current practice of high speed, for example, visual inspection is done through this truck that many of you actually saw it parked outside. So this is what we've actually called our high-speed inspection truck. I mean, many of you, as you have seen it, and we have gone over the equipment, so I'm going to make the rest of the presentation more about the results than the equipment. But if we want to quickly go over what we have on board this high-speed inspection truck that is going to facilitate the visual inspection for the inspectors, we will be capable of, we are capable of actually conducting the inspections and data collections at speeds of 40 miles per hour or higher if needs be. We have a 360-degree camera here that you see it actually on top of the truck right now, and since this picture was taken, we moved that camera toward the front of the vehicle, and it gives the inspectors this immersive view of the structure as the inspector is walking the structure and then looking around. We've got LiDAR for actually making sure that we would be able to do measurements, high-speed chain drag that we're going to talk about it, surface imaging and crack mapping, infrared for thermography if there are favorable weather conditions, surface profilers, GPR, and some other tools to actually make sure that we know what the local coordinate system of the bridge is and where the data is actually being collected. So if you want to actually see a quick sample of how the data is collected, it is collected like this, and we are done. So this is a kind of local bridge in north of New Jersey, actually. So the bridge is around 150 feet long and 32 feet wide. But as you saw, that is all it took for us to collect the data that we required, for example, for the purpose of our visual inspection. And that enables the inspectors to actually start their inspection job from the safety and comfort of their computer. Now, this is a small bridge. Now imagine the possibilities for a lot bigger bridges, interstate bridges, and likes. So as we discussed, real-time monitoring and quality control is very important, because whatever we collect and give to the inspector, we want to make sure that we actually have them at the best condition as they can be. So we have software quality control in place that does everything in real time, and we have operators who are literally, while the data is being collected, are sitting there and then are monitoring the data that is actually coming in, so that if we see problems, we can actually take care of them literally in the field, or if it is not possible to take care of in the field, we will mark the data so that they wouldn't actually pollute the final results. Now, when it comes to the delivery, we have an online portal that the users would be able to actually customize it, to the fees, to their own liking. But we are going to go over some of the results that are mostly videos. We were talking about giving the inspectors the kind of option and capability to walk the bridge. This is a bridge actually in Louisiana. It is a 1.2 mile long bridge, 4-lane, that we actually did it for their complex bridge design team. They wanted, one of the functionalities that they were really looking for was, because they couldn't really close the bridge to traffic because of so many conditions and schools being nearby and things like that, they wanted to actually have this ability to walk around the bridge and look at things. So literally we facilitated that for them. Now we can do our visual inspection through many of these sensors, and then with some other tools, for example, integrating with Google Maps, we would be able to actually give you some other view into the surrounding and other things that actually inspectors use. Google Satellite is one of the things that we actually use quite often, and that is pretty much integrated into the system too. You wouldn't need to actually switch between this system and Google Maps to actually, for example, check out the surrounding. But the other thing that we've actually done is, by this system, we are giving the inspectors what I would like to call Superman vision as well. because not only the inspectors would be able to actually look around, and sometimes which wasn't really possible, but we would be able to actually help them move quickly from location to location. For example, right now, as you can see, we are moving, from span to span, and we are looking down. But then at the same time, if you would like to actually, for example, zoom in a little bit more, that you would like, for example, to use something like a magnifying glass to actually check that, that would be, again, possible to do it right from the inspection portal as well. Or even if you would like to actually see subsurface, for example, information, that is why, I would like to call it Superman vision, you would be able to actually, again, go to the subsurface and then see what is happening below the surface as well. This was, for example, one example of, the joint inspection, that as you saw, we would be able to actually zoom really into the joint and then, check out, for example, the integrity of joint seal. We talked about crack mapping. So we have, high resolution cameras taking picture from the surface, and then we have trained, the AI to detect the cracks. And based on the criteria and the width categories that the user defines, the system actually paints over those cracks for you, calculates the total length of those cracks, on the bridge, and then reports everything back to you. We've got, density maps based on, those calculations. You can actually turn it on and off, and then see where you have actually, for example, higher density of the cracks, lower density of the cracks, and then remember that we've got chain drag data, so you will be able to actually see where you see a lot of cracking, what is going on, below it. Are we having, for example, shallow delamination in that area or not? Again, that is like totally possible, and that is, again, something that I would like to say contributes to that Superman vision that we talked about. You want to have a high view into your bridge deck and then see what the status of the cracking is. So you're looking at the density map, and then you see a red spot. That means an area with a lot of crack compared to, or bigger cracks compared to all other areas on your bridge. And that could be, literally your focus area on something really quick that you want to do with that bridge. Again, that is all possible from here. But the other thing that, we made available is like the power of customization. So literally, if there are things, because we know that bridge to bridge, inspector to inspector, program to program, there are so many differences. If there are things that you would like to do, for example, again, Ben, back to your question regarding time pressure, if there are things that we will be able to actually implement here based on, a specific owner of, for example, different districts, we would be able to actually implement them here as well, with the idea of, increasing, the efficiency of the work and removing, that time pressure that we're talking about. We want to do measurements. That is something that we all would love to actually do in the field, but most of the time it is not possible. But it is pretty much easily done from the system. If it's linear measurement, if it's perimeter of a feature, if it is like a square footage of a feature, those all can actually be done straight from the inspection portal. Now, when it comes to actually seeing something and marking it, again, we are training another AI engine to actually start detecting features. Right now, that engine is trained for cracks, so if we see cracks anywhere, we would be able to actually do it. But now we've started to actually train that engine for spalls as well. So when the inspection work begins, for example, by state inspectors, when the system is actually activated, it comes with some I would say, picked problems. For example, right now we are working on a spall, so the system would actually find the spalls and mark them for you. And then it would automatically actually go ahead and, for example, fill out the NBE or NBI form based on, the problem that it actually found. So we already know where the location of the, for example, defect is. The system already knows it, so it's going to, jot down the location for you. It's going to take a picture and automatically attach it for you. Some other, for example, screenshots from the work that we did for Louisiana DOT. And this is, a quick kind of look into how the process is actually done if, an inspector wants to actually do it manually. So you see the problem, you actually would like to annotate it and log it for use or for being part of your inspection report. The system is going to ask you whether it is like something personal or you want to actually make it, formalize and assign, for example, in this case, an element detail to it. And then the user actually goes ahead and then chooses, the element level, for example, detail. And based on where the location of the problem is or where the location of the defect is, the form is going to change in a dynamic mode, or it's going to change dynamically. You give the information, and then it logs it for you with everything you actually provide to the system. Now, there is this kind of connection between the forms as well as the defects too. You see the published form. You see, for example, there is like this area of spalling on the deck with condition state 2. You want to check it out right there from the form. You click on that area, it takes you back, to where the picture was taken from. Or if you see like an annotated location and it says it is showing up on your inspection form, you click on it and it takes you to where the form is. And the forms we are actually currently we are streamlining the process so that you can literally file and transmit the inspection file to FHWE as well. And another kind of feature that many of our users asked for, and then we actually added it to the portal, many of the owners that we are working with, that is like to just see a video as if we were like driving the deck. So we added that as well for use by inspectors. This is like a dynamic form builder that we already have there. So based on the different type of inspection, you can dynamically add in what you will need. If the system has already picked them, it's going to be pre-populated. If you pick them using the system, again, it's going to be automatically populated for you as well. As we just discussed, it already has many of the information to log the problem for you. We already covered this, but we talked about the bidirectional kind of connection. It is editable and collaborative. We have actually built in task assignment, management of tasks, and communication between different users of the form as well. Now going into chain drag, it is like this part of the system that is actually within the footprint of the vehicle. It is here. Again, we can go over any speeds. We can get started from even like walking speed, but at 40, 45 miles per hour, the system actually works very well. The good thing about this system is that we wouldn't need any kind of lane closure, and the results are, a lot better than, the chain drag that we all do, because most of the time we are relying on our ears, where, a lot of, sound as well as, noise in the background is going to prevent us from actually listening to what we got to actually listen to and hear the defect. But, this system, we use high sensitivity microphones. We do a lot of quality control to remove, all the, bad data, not bad data actually, I would say all of the junks that we actually hear from like surrounding environment, and just look at the meat of the signal that is coming from the pavement or from the delamination. This is, for example, a sample of the chain drag survey that you are looking at. The red areas are the delaminated area. This is coming from a project that we did for Iowa. And then the areas that obviously are not colored, they're the intact areas. And the yellow areas are part of the, I would say, concrete that doesn't give us like the sound response of the intact concrete, and it doesn't give us like the exact response of a fully delaminated concrete. It is like somewhere in between. Now, some owners asked us to actually put it in like a different category for them, and some owners actually have asked us to combine it with either intact or either the delaminated area. It is highly repeatable, so this is like another project for a county in New Jersey. As you can see, it was a movable bridge. We did chain dragging at 2 different times, 4 weeks apart. Top and bottom are 2 different results from those 2 different days. The patterns are the same, and the delaminated area for one is 13.6%, for the other one is 13.08%. And some of the other data that are coming out of the high-speed system to actually give that Superman vision to the inspector to actually see what is going on really below the surface. Now, if we go into the kind of area of multifaceted NDE, or going back to the earlier conversation of doing our high-speed test and then doing more in-depth test, we have like another tool in the toolbox that we have called it our high-definition system that, again, many of you saw it parked outside. So here is where that really notion of medical practice that we talked about comes in, because the smart, kind of most optimized way of optimizing this equipment is to deploy the high speed, which is, again, no lane closure required, and take the MRI machine, or that MRI machine on 4 wheels, to only where we actually need it to be. This system, using the sensors that it has and the way that we have automated it, is really the fastest ground coupled system. So although we're going to require lane closure to actually deploy this system, but we know that it is optimized and it is the fastest system that can do ground coupling for you that is out there. But if owners want, the same way that we've been seeing for the past few years, sometimes based on the need, we either just deploy the high speed, either just deploy the high definition, and in some cases we actually bundle the two. But all of them, they come with the inspection and asset management portal that you actually saw. So on each one of these sensor trays down here, we have impact echo that finds, whether it is shallow or deep delamination for us. The sensor actually finds it. We've got ultrasonic surface wave that actually finds and reports back to us the estimated modulus of elasticity of concrete to us. We've got electrical resistivity that gives us a very good estimation of the corrosive environment at the rebar level. And we've got ground coupled GPRs that give us, the top cover dimension as well as moisture ingress. Now our linear speed is, because the data collection with this truck is like kind of on stop and go, our speed is around 5,700 square feet per hour at full deployment. And full deployment means we have all of the arms deployed from this area to this area. We are looking at around 19 feet. So this system is ideal for when many of the states are going into, for example, letting out a contract. They want detailed quantity estimates. They want to know the location of all the delaminations so that that contract can actually go out nice and easily. And if you look at this video, this is how the data is collected. I want to get to the case studies as well. There are 2 layers of quality control, just like high-speed system, automated and by operator. I've been asked so many times during our conference that if there are any high-speed solutions for asphalt-covered overlays, asphalt-covered bridges, and the answer is asphalt is gonna kind of make the action of accessing the bridge deck difficult, but it is not the end of the story. We always have the power of integration. We can deploy different sensors that would actually give us different views into the structure. We can start looking at the bridge from underside if the access is possible, and putting all of those data points together, we would still be able to make some good determinations about asphalt cover overlay, asphalt covered bridges as well. This is like a sample of, for example, imaging from underside, where you see like this nice delamination popping up to you when you are doing infrared thermography compared to the RGB image. Again, drones, we already talked about them. We've done that for a few states as well as part of making like a holistic inspection of the structure. Delivery and reporting, you already saw some screenshots, but as we discussed, all the dashboards and literally everything that is in that inspection portal is customizable to the needs of the inspectors, and you can actually print out your own in-depth PDF report out of the portal as well. So like 4 quick slides on some of the work and how different states actually used this system. This is, for example, the Louisiana DOT worked on the historic bridge that we actually talked about. They wanted several things out of the system. First off, the design folks, they wanted to actually be able to walk the bridge. So that is what we actually gave them. But then at the same time, because they couldn't close this bridge, they didn't have any chain drag data. So all of the planning and rehab planning for this deck, as well as they were thinking about actually applying the application of overlay, was being done by kind of time-based models and gut feel of the folks in the design team. But we managed to actually finish up this whole bridge in less than 2 hours and then get back to them with all of the results in a week. So 4 bridges that we did very recently for Delaware DOT as part of the Restore the Corridor program that they have going on with these I-95 bridges. Because of the scope of the work and criticality of the situation, we wanted to make sure that we go into the design, we go into the contract, knowing that how much damage exactly we are looking at, where are the location of those damages, and these bridges that you're looking at, they have gone through several rounds of widening over the past 50, 60 years. So we wanted to know actually what is the status, what is the condition of each round of widening that has happened on these decks as well, and this is where we deployed our high definition system to get the asset owner, DELDOT, the exact kind of information that they would require to put together their design plans. Iowa DOT used both high-speed and high-definition system for their preservation and rehab works on around, if I remember correctly, I have it actually here, on 15 bridges. We had bridges with deck area of around 2,400 all the way to 30,000. There was like a mix of like 7 bridges for coming up in their biannual rehab program, and another 7 bridges they wanted to do preservation action. And then the last case study is from Oregon DOT for the folks who are going to the Boise, Idaho meeting. We have a session actually dedicated to review of these results with the folks from ODOT, Andrew Blower, at the time of the work, was in charge of preservation, and he's going to be actually presenting with me. We are working on the slides, and we're going to go over all of the results together. But again, we had like around 21 bridges, deck area from 2,800 all the way to 189,000. And then we, again, deployed both of the system, high speed and high definition. They had planned for both preservation work as well as rehabilitation work on these bridges. And with all of the data as well as reports that we actually generated, we kind of produced enough information that designers could actually use for this. And the last slide that I have here is we were actually notified on Wednesday that a proposal that we put forward to use some field studies to establish NDE protocols for use in early stage bridge deck preservation strategies was received a lot of high interest from the NCHRP IDEA grant panel, and we will most likely get awarded with this grant in the next month or so. There are like some comments that we got addressed for them, but they said most probably we're gonna have that grant. And here again, the idea is we come up with like some protocols that are driven by data, that are driven by NDE kind of metrics to find preservation triggers. And for this, we have support, and we have some bridges given to us by Delaware DOT, VTrans and Iowa, but we are still looking for other participants, asset owners and bridge owners, especially in our area. I mean, we are a Pennsylvania as well as New Jersey based company. So if you folks, would like to actually attend in this study and, give us some bridges to do data collection and then report back the results to you and include them in this study, which is, sponsored by NCHRP, we would like to actually talk to you and then go over, the scope of data collection. So I'll just finish it up here to see if you folks have any questions. Otherwise, my contact information are here, and in the conference material. I would really appreciate if you have comments or questions. Please feel free to come back. Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.